G'day grade 9s, welcome to the third video in our Year 9 Geology unit, Natural Disasters. We're going to look at volcanoes and hotspots. So let's get into it. We're going to learn two things: what are volcanoes and what is hotspot volcanism. So we should be able to recall some major features of volcanoes, where they're located, and describe hotspot volcanism. Why is it different to our usual volcanoes, as usual as a volcano can be? And the reason why, as I said with our first one, is both volcanoes and earthquakes. These are major bits of evidence for the theory of plate tectonics. So, volcano is pretty simple. It's any opening, doesn't matter if it's a big mountain or just a little crack in the ground, any opening that lets molten rock, magma, out of the mantle. Now, just for a bit of language fun, once it gets out of the earth, once it's on the surface, we then call it lava. So magma inside the earth, lava when it's on the surface of the earth. Chemically the same stuff, be a bit colder because it's cooling down the air, but otherwise same stuff. And we give them one of three classifications: it's active, it's dormant, or it's extinct. Now there is a video to go along with this, so I'll load up the OneDrive and take a look at that. And here's a pretty straightforward sort of classical picture of a volcano. You've got your mountain looking thing, but big things are important. Here we've got our magma chamber, the bit where we've got all this magma building up before it erupts. You've got your lava coming down the sides. You've got all these sort of conical shapes underneath it, which we'll get to shortly. And this bit coming down the surface, we call this the pyroclastic flow. Okay, pyro meaning fire, and clastic in this case is sort of referring to a medium in that it's not quite a free-running liquid, it's not a solid. Little bits of solid material that go flying are called volcanic bombs. And sometimes you get these secondary events and secondary cones. Now I have said to write this down, but sketch it out. Don't do a faithful copy. You've seen my terrible drawings in class. Give it a rough Mr. Warren impressionistic style of drawing. Impress me. So, those three statuses that we have for volcanoes, anything that is currently producing lava or volcanic gas, or any sort of seismic activity nearby. Remember, seismic means earth. We call that active. Dormant is where we say it doesn't seem to be having any of this, but could go off again. And then extinct, we say no eruption for 10,000 years. Now, if we consider the fact that the Babylonians started establishing their civilizations around 6,000 or so years ago, something to be extinct has to be non-eruptive for a very, very long time, nearly all of recorded human history. So, volcanic, when we talk about the damage that they can do, it's all about the pressure. Right? If the volcano can just let its lava out whenever it wants, then the lava just oozes out. It might have a bit of a splurt, look quite impressive, but good light show, but it's not going to cause too much damage. There are some volcanoes in Italy that are kind of like this, and they're very close to cities, and while they may be active, they don't cause too much damage to the surrounding areas. But if things get clogged up, then that pressure builds up, kind of like a really nasty whitehead that you might have as teenagers, and then eventually, pop, it explodes, and everything that's inside comes out. And that's what happened to a fairly famous volcano called Krakatoa. Krakatoa was a volcano that erupted in the Southeast Asia through the Indonesian archipelago, and it really messed up the whole world. And there's a fantastic video on this. Have a watch of that, because there are some wonderful stats that you guys will enjoy having a look at. So if we think about our types of volcanoes, different volcanoes will have different shapes, and it all really depends on the type of material and what sort of eruption. You got your composite, they're your sort of standard, traditional, hey, I'm a mountain but I'm a volcano type things, because the lava cools down really quickly, so it doesn't get to go very far. So this one right at the bottom sort of oozed out and then went, yep, we're here, this is where we're staying. And so the next one has to come up a little bit higher and then start running down the sides, and again quite steep, and it builds from there. Cinder cone volcanoes, they throw out a lot of ash, so things spread out a lot more. Shield volcanoes, the lava sort of oozes out and then starts spreading out sidewards out of the vents. You got your fissures volcano, where things sort of pop up and just spread actively out there. And your calderas, those are the really dangerous ones. Your calderas have this plug, often of basalt or granite, that igneous rock that you learnt about last year, very, very hard, and it clogs up the volcano, and this causes the pressure to build up even more and more. And this is the important bit. Now, there is a worksheet for this on eLearn. Definitely get a copy of that, and we've provided one in your booklet if you happen to be working at home from the booklet. But this is an important map, and I want you to think about this map compared to the earthquake map, about where those volcanoes are. So I'll give you a minute to dig up that extra map. So pause the video, go find the earthquake map, or if needs be, load up the earthquake video as well and run it forward to you looking at that map, and look at them side by side and see what you can notice here about their similarities. Oh wait, go get it. No, I'm serious, go get it. Okay, we've got it. So, if we have a look here, we can see that there is this massive set of volcanoes down the western coast of the Americas. Same with the earthquakes. Going across here through Alaska into Russia, down through Japan, down through the Philippines, Indonesia, down to the North Island of New Zealand, which was where all those earthquakes were as well. There's a fair chunk of earthquakes here up through the Horn here of Africa in towards the Arabian Peninsula. Again, there was quite a number of earthquakes there as well. There were more earthquakes. For example, there's a few volcanoes here, but there was a lot more earthquakes down through there. Same as well along the bottom here above Antarctica. A lot more earthquakes, but not as many volcanoes there. So there seems to be some correlation that where there are lots of volcanoes, there are lots of earthquakes. But there are some important ones, like here we can see all these random volcanoes just sort of sitting out here in the middle of the Pacific. Hey, there's one sitting here off the bottom coast of Australia. A couple up here in the Arctic Sea. Okay, so there's a couple of just sort of random ones. If you look at this little red glob here, that's the nation of Iceland. Again, lots of earthquakes, and they have a lot of volcanoes. They had a volcano a few years back that was so put out so much ash it stopped air travel across most of Europe for a few days. I'm not going to try to pronounce it because Icelandic names are horrible to pronounce. So let's have a look at some famous volcanoes. Mount Fuji, huge. It's dormant. It could erupt again, but probably unlikely. But has intense religious significance to Japanese cultures. We keep going forward. Mount Vesuvius. Okay, they thought their god Vesuvius, the Roman god of the forge, lived in that volcano. It's a Pompeii, a bit south of Rome. It destroyed the town of Pompeii in 79 AD, and the volcanic eruption was so severe that people just couldn't escape, and they died from the ash, and their bodies were preserved. And they're still excavating there. You can go visit this. Krakatoa in Indonesia, and in 1883 it changed the global weather systems. The eruption was that big that it changed the weather worldwide, which is pretty massive. Now, if you've ever seen the painting The Scream, where the person's sort of all wiggly in their shape and they've got their hands around their face with their mouth open, like going, ah! There was an explanation for the weird colouring in the sky, in that it was painted shortly after this, where global sunrises and sunsets started to look a lot different because there was a lot more ash in the sky for a couple of years. So, Krakatoa not only changed world weather patterns, but made some pretty cool art. So, in contrast with volcanoes, we have something called hotspots. And so a hotspot is what we say any area of volcanism, volcanoes, that doesn't appear near a plate boundary. Now, we haven't gotten to plates yet. We'll talk about those in our next video. But for now we're just going to say there are these plates and they have boundaries, they have edges, but any volcanoes that don't happen near them are different. We call them hotspots. And this is called intraplate volcanism. Intra means within. Okay, so if you have intrapersonal skills, you have good self-understanding of your own emotions and feelings and how you communicate with yourself and others. If you have good, what's another word that starts with intra? The school has an intranet, the bit that only the computers at the school can talk through. Right? And then inter is the opposite, meaning without. So internet, the connection between different computers, interpersonal skills, communicating with other people. And we don't know for sure because it's very hard to go down into the mantle. We think the hotspot is created by an area of mantle, that layer underneath the crust, that is hotter than the area around it, and that causes the magma to just well up in that area. And so, because our plates move, hotspots also look to move to our perspective. They end up making these chains of volcanoes. The ones that are very far from the hotspot are extinct, the ones close to it are considered dormant, and the ones right over the top are active. And because the tectonic plate slips off to the side, it ends up creating this chain of volcanoes. Now, we see it because we tend to think of the Earth as not moving all that much, that the hotspot is going this way, but it's not. Okay, the plate is sliding over the top of it, okay, while this stays here. Let's bring the head up. Okay, so the plate is going this way while the hotspot stays in spot. But from our perspective of some little guy just sort of standing here, let's rotate that so can't quite look, you can barely see the bump. We sort of see it as, oh, the hotspot's here, but now it's going that way, and it moves and creates new volcanoes. And so there is a really important difference between our two different types of volcanoes. We know something is a hotspot volcano if we have a chain of extinct into dormant into active volcanoes, while volcanoes that are made by a plate boundary, until those plates completely go under, subduct under each other, which isn't really happening in our lifetimes. These are very long processes we're talking about. Those volcanoes will always remain active in that area. If we think about that volcano map, the volcanoes off the coast, down the coast of South America through the Andes Mountains, they all stay active. Right? Even if they stop erupting for a few dozen years, they're still active volcanoes. While Hawaii is a fairly important, and as I've got here, the Hawaii hotspot, so we will go back to our map of volcanoes. The Hawaiian volcano, well, they out here, you can see this volcano here is no longer active, but this one here right at the very right end is active. And you can go and visit it, but over time, let's say another 1,000 years from now, that volcano probably won't be active, but a new volcano will be bubbling up very close to the current islands of Hawaii, if not already above the surface. So over time, these volcanoes will make a stretch of extinct through to active volcanoes, but these volcanoes here will stay active until the interaction between the Pacific plate here and the South American plate, I think it's the Nazca plate, is about here-ish, but until whatever two plates here along this border stop interacting together. And that can happen if one plate gets entirely chewed up and then there's just two plates sort of sitting next to each other, whichever's over on this side coming together as things move around, then ideally, in my imagination, if the plates are no longer being pushed together and having any subduction, which leads to volcanism, then there's not going to be any more. That's what I'm looking for. Any more volcanoes occurring there. Okay, so if we go back to that last page. This area here where this plate is coming underneath this other plate, if we don't have this, which leads to upwelling of gases and rock due to the heat as it starts to melt down, then we won't end up with any volcano there. So we need that subduction event. Alright, now as I recollect, that should be the end of this video. So, you've got there some stuff on volcanoes. There will be a video on tectonics coming, plate tectonics coming out a little bit later. Try your best. There's some questions on the discussion board for you to answer as well, and I will see you soon. Bye guys.